So in example 4, we're rolling two four-sided dice and we're adding together the numbers that are shown on the two dice. So in part A, we're going to draw a sample space diagram to show all the possible outcomes. So on the first dice, we could have 1, 2, 3, and 4. And on the second dice, we could have 1, 2, 3, and 4. So this is the second dice, and this is the first dice. And then in our sample space diagram, we're just going to show all the possible combinations of the scores that you can get. So if I had a 1 on the first dice and a 1 on the second dice, I'd have 2. And we can go through and fill in the sample space diagram. Okay, so we've got 16 different possibilities, and in part B it says, given that at least one dice lands on a 3, find the probability that the sum of the two dice is exactly 5. So we know that we're in the part of the sample space diagram where at least one dice lands on a 3. So let's circle the possibilities in our sample space diagram where at least one of the dice is on a 3. So we could have all the possibilities where dice 1 lands on a 3. So that would be that one, that one, that one, and that one. And dice 2 could also have landed on a 3. And notice that here, when the first dice lands on a 3 and the second dice lands on a 3, we're allowed that because it says at least one dice. So we are allowed both dice landing on a 3. So it says, given that we're in this region of the probability space diagram, find the probability that the sum on the two dice is exactly 5. So now we're sort of zooming in, and our sample space diagram is only those circled numbers. So they're all equally likely, and we've got 1, 2, 3, 4, 5, 6, 7 options. And out of the 7 equally likely options, we need to work out how many of them have an outcome of 5, a score of 5 on the two dice. So we've got 2 out of the 7 equally likely options. So that's the probability of landing on that. We could have also got to this answer using the formula for conditional probability. So we want the probability that the sum on the two dice is exactly 5. So the sum is 5, given that we know at least one dice lands on a 3. So at least one dice is a 3. So our formula for conditional probability is that's going to be the probability of this event happening and this event happening. So the sum is 5, and at least one dice is on a 3. Divided by the probability of the event that's conditional is happening. So divided by the probability that at least one dice is a 3. So remember, these probabilities now aren't conditional probabilities. This is just saying if I roll these two dice, what's the probability that the sum is 5 and at least one dice is 3? So that's a probability that's going to be out of 16 because there's 16 outcomes in my sample space. Well, there's 2 options where the sum is a 5 and at least one of the dice is a 3. That option there out of 16 and that option there. So that's 2 outcomes out of 16. And on the denominator, we've got the probability that at least one dice is a 3 when I roll the 2 dice. So again, it's out of 16 options because it's not conditional anymore. And at least one dice is a 3. So we already know that probability because there's 1, 2, 3, 4, 5, 6, 7 choices out of the 16. So the probability of that happening is 7/16. And again, we can times through by 16, times the top and the bottom by 16 to get 2 7s, which is the answer that we got before. And then in part C, it says state one modelling assumption used in your calculation. So we've used the fact that each of these outcomes in the sample space is equally likely. Because, for example, here when we said the probability is 2/16 that we're in this circle or this circle, well, if one of the numbers was more likely, then it wouldn't just be 2/16. So in part C, we've used the fact that the dice are fair. Meaning that each number is equally likely.